Hi guys and girls on YouTube and welcome to my channel. I've got an interesting fault here in a Pioneer. It's like all little separates, a hi-fi system. Now the fault is it actually switches off before it's come on, if that makes sense. And on the display on the front the letter H comes up and then it says goodbye. Now I would presume that the letter H is the start of a scroll that says hello, but before it's actually completed it says goodbye and it switches itself off. So it's some sort of trip, but I only have the diagram for this top part, which is an A-P510, and there's no technical description in it, so it's a bit of a tricky one, but let's just see the fault first. Right, so that's the power button. I'm going to press that, but we're going to move the camera down to the display and you'll see what happens. Oh, that's the wrong display, it's the one underneath. Right, let's try again then. So if you see there, the letter H flashed up and then it says goodbye, and now there's some dashes. Let's just try it again. And also I can hear, like, in the momentarily space of time it comes on, I can hear a fan. I don't know if you can hear that in the video. So where do we start fault finding with a thing like this? Well, I've really no idea, and I would imagine it's a problem with the audio amplifier. Perhaps it's DC in the speakers. So what I'm going to do, because it doesn't stay on long enough to find any problem, and with no hints in the service manual, down here there's a relay that turns the power off to it. So what I'm going to do is I'm going to clip a 60-watt bulb across the relay contacts, and that will keep power to this all the time. It'll keep it running all the time, and we can make some more meaningful tests. And then of course if the output audio amplifier chip is short circuit, then the bulb will just light up very bright and we won't cause any other damage. Right, so that's the 60-watt lamp connected across the relay. I'm going to turn it on behind me. And the first thing you'll notice is the fan is actually running all the time. Which I wouldn't have thought it should be running in standby, because don't forget this thing's not on. So let's just press the button now and see what happens. Right, nothing. It's no different than it was before, but the fact that the bulb's not lit up means we don't have a short, and because the fan's running all the time, I would have thought the fans only run when these get hot. So the first thing to do now is to have a look at the circuit diagram. Right, so we're looking at the circuit diagram of the fan circuit. Now if you look, there's a thermistor and a couple of op amps. So obviously that fan shouldn't be running until this gets hot. So that's the first clue. Now if we examine the fan driver, you'll see these two transistors there. This bottom transistor actually takes a signal from that op amp, and what it does, it shorts the base of that to ground, which will turn the fan off. So the reason the fan is running all the time is because this transistor here is biased by this resistor from the 20 volt HT rail. So this transistor here that actually turns the fan off must have no base bias. Now if we trace that back to op amp, it's a pretty simple circuit, that, and the first thing we need to do is we need to check the supply voltage. Now because this is an op amp, you've got a plus and minus supply, so we look at that, we've got plus 4.97, so it's going to be a 5 volt rail. So we've got plus 5 volt rail there, and this pin here will have a minus 5 volt rail on it. So we're just going to have to move that across a bit. Now that plus and minus 5 volt rail comes from IC803. So on pin 5 we've got +5, and on pin 12 we've got -5. So they could be missing, and if we check this circuit back here, you've got two integrated circuit protectors with -11.3 and +11.2. So it's highly likely that one of them is open circuit, and we've got no input to here at pin 1 and 16. So that's the first thing we're going to check now, is them circuit protectors. Now, I don't know if you can see on this, but that's one of the circuit protectors down there, and the other one's down here. I've checked both of them are alright, and I've checked the inputs to this IC, about 10, 11, 12 volt, they're okay, but we don't have the plus and minus 5 volt output. So what I'm going to do is I'm going to pull up a data sheet for that IC and see what that does. Right, well that's the data sheet for the IC in question. It's a Mitsubishi M5290P, which is basically just a plus and minus 5 volt regulator. On here we've got a reset output to the micro to tell it if the outputs have failed. There's an on and off, which according to this, when pin 10 is connected to ground, the outputs switch off. Also we've got two transistor outputs so we can drive a higher load, but the outputs I've got missing are here, pin 5 and pin 12. Now in the Pioneer diagram, a lot of these pins, like the micro reset output and a lot of these other pins, aren't actually used. It's a lot more simpler than this. So this is the diagram now for the unit itself, and if you look at this, a lot of these pins are actually just connected to ground, and the ones that aren't connected to ground aren't used anyway. So we've got the input to the IC, we've got no output. The only thing it can be is this chip that's faulty. Now actually, before we condemn that chip, I've just had another thought. This chip, the outputs can be turned on and off by connecting pin 10 to ground. So let's have a look what's actually connected to pin 10 in our unit. Right, so back to the Pioneer diagram again. If you look at that pin 10 on off, that's actually connected to a 10 microfarad capacitor straight to ground. Now that will delay the switch on of this IC, but if this capacitor was leaky, that would hold this IC off. So the first thing we need to do is to check this capacitor before we change the IC. Which brings us to a slight problem now. The capacitor is right down there. I can't point because I'm holding a torch as well as a phone, but you can see it just leaning to one side, and it's next to the brown cap. Now this is a very, very difficult thing to work on. There's no access from underneath. So if we look at the underneath, there's no access. So what I'm going to do is I'm going to try and cut one leg of that capacitor with these horrendously expensive Lindstrom cutters. And if we can just get the capacitor out of circuit, then we can eliminate that, because the only way to work on this is to remove everything out of its case and reassemble it back on the bench. Well, unfortunately there's not enough room to get these cutters in to cut that leg on that cap, so I don't have any alternative other than to take all this lot out of its case, which is a bit of a pain, but there we go, it's just one of them things. Right, so that would appear to be the best way to work on this, is just unscrew everything there is, including the transformer, and just pull the bottom off. So now we can turn this over. Well, I have to put the camera down because I'm holding it with one hand, but we can turn it over now and look at that capacitor underneath. Right, so we're looking underneath, and the first thing I can see is the hot spot there. It looks like a couple of transistors and a resistor. Now they're very badly dry jointed. You can see it's got very hot. I'm not sure what they are. We'll have to have a look at the service manual, but that'll need attending to. But more importantly, I've just spotted something here where I suspect the capacitor might be faulty, or it might want testing to see if it's faulty. There's actually some corrosion around them. There's two capacitors there. There's some corrosion around them, and they seem to be connected to this chip here, which I suspect might have something to do with the problem. Let me see if I can get that under a microscope, or maybe on my mobile phone to get a better picture, because I don't know what how much detail you can see on this camera. Right, so that's the picture on my phone. We're looking at there. You can just see there, it's all green, and it looks like it's had a liquid spill, but when I look in the base, I can't see anything in there. And don't forget, this is the underside of the board. You wouldn't spill liquid on the underside of the board. You'd expect to see something on the top. So my guess is one of them two electrolytic capacitors there is actually leaking electrolyte, and it's come through to the other side of the board, and it's probably providing a conductive track, and maybe that's why this IC's got no output. Oh, we can zoom in with a camera. That's better. So there you can see where it's green, and there appears to be it appears to be wet as well, like so I wouldn't be surprised if that's conducting across from there. So I think there's two capacitors under here. We're going to have to take them both out and have a look, because they're definitely connected to the chip that has no output. Right, so the capacitor I thought might have been causing the problem, C819, that is actually okay. You can see the two holes where I've taken it out. So now let's turn attention to the next one to it, that I think could very well be leaking electrolyte. Right, so this is the capacitor where the trouble seems to be coming from. It's only decoupling the collector of that transistor, because the negative of it there is actually returned to pin 9 on that IC, which is ground. So I've got that out. Let's take a look at that now. Right, well that's the answer to that. ESR of more than 20 ohms, that is faulty. And I don't know if you can see, I don't know how clear it is on the camera, but you can see one leg on the capacitor's green. So that is almost certainly leaking electrolyte, and that's what's contaminated the back of the PCB. So I'm going to have to clean all that PCB up and see if there's any more damage first, because it might have eaten the tracks away. Right, so as you can see here, it has caused a little bit of damage to the PCB. It's not actually eaten the tracks away, it's only eaten the green coating off the top. So I think that will clean up with a fiberglass pencil, and then we can spray a bit of lacquer over that. But that was the cap in question there that's been leaking electrolyte, and you can see where it's spread around. Actually, it's not that evident on the camera, but I've just noticed it has eaten through one of the PCB tracks. I've just measured it with a meter. If you see this connection here, goes there and it goes round here, but I've no continuity between there and there, and you probably can't tell on the camera, but just there it's actually eaten the track away, so there's no continuity between that and that pad there. So there is damage to the PCB. See if we can zoom in. No, it's not very good. But there is some damage that we're going to have to do just there. Right, so I'll just have to very carefully clean the top of the board as well, and then we'll fit these two new caps, and I'll repair the PCB in a minute when the caps are in. Right, that's the PCB all repaired. You can just about see the fine piece of wire I've used to repair the track in the middle of the screen. So let's just clean that up now, make it look nice. Right, so that's cleaned up very nicely. You can see where I repaired it. I'm just going to attend to these dry joints here now, and also this other little hot spot here at the front. We'll just attend to that, and then we'll plug it in, see what happens. There you can see now the piece of wire I've used to repair the tracks. Right, now it's not all screwed back together, this, it's just placed in its case, and I've just put one screw to hold the transformer down. But let's set the camera up on a tripod. Right, here we go. I'll just turn out the light, switch it on at the mains. That's the power button there. Oh, look at that. It does say hello when you turn it on. And if we turn it off, it says goodbye. So what a good result that was. All we need to do now is to screw it all back together and give it an audio test, but I'm pretty confident, considering it didn't come on before, it'll be okay now. Right, so there we go, guys and girls. Many thanks for watching, and I'll catch you in the next video. All I've got to do now is tidy up all this mess, and of course put all the screws back in. Alright, I'll catch you in the next video, everybody. Goodbye.